So this is worksheet 3, number 8. I think this is the worksheet that said you can use a calculator unless it says otherwise. Also looking at my answer choices, I'm pretty sure this is a calculator problem. What is the volume of the solid generated by revolving the region bounded by y equals tangent of x, y equals cosine of 2x, and y equals 0 between 0 and pi over 4 about the line y equals 1? That's a lot of information going on there. So y equals 0 and x equals 1. Tangent. I mean, I know roughly what tangent looks like. But I've got a calculator, so let's don't mess this up. Let's just go to the calculator. So y equals tangent of x, and y equals cosine of 2x. And I can go like change the weight of these lines, but I know what tangent and cosine generally look like, so I'm not really worried about being able to tell them apart. So I'm just going to leave them both as, whoops, if I can get back there, just the regular lines. From 0 to pi over 4, so that needs to be pi over 4, about the line x equals 1. So I think 1 is bigger than pi over 4, so that's good. Let's see what this looks like. Okay, that's too much. Let's go from -1 to 3 maybe. And I don't know how far up and down we need to go. I'm going to try -4 to 4. Okay. You know what? I'm going to put let's go to pi. No, I don't want to go to pi. Maybe if I just go to pi over 4. That'll. So that was tangent. There's cosine. So somewhere in there they intersect. So tangent does that. Cosine is doing that. I'm going to call them y1 and y2. And we want to rotate that thing around x equals 1. So, goodness, this is going to be weird looking. Cosine of 2x. 0 to pi over 4, x equals 1. I mean, yeah, this is just. I'm going to zoom in a little more, get a better view of it. Oops. Yeah. So I'm going to try to mirror this across. So my y1 starts at the max and goes to the minimum. And y2 kind of goes the opposite way. This is a weird shape. I think I'm going to have to do this like in stages or in two different integrals. impossible. Not impossible. Tricky problem. So let's do the blue one first. Well, template is pi r squared minus pi r squared. Are we going dy or dx? Can you tell how these things are stacked up?
dy.
That'd be dy. Yep. So everything's got to be in terms of y, which means that x equals inverse tangent of y. This problem is awful. And 2x is the inverse cosine of y. So x is the inverse cosine of y over 2. I switched those because I know I'm going to need them in terms of y. dy, so I need to go from 0 to the top. Don't know what the top is yet though. So I need the other one. Yeah, cosine of 0 is 1. So that's 0 to 1. But the trouble is, let's see, outside minus inside. Like this is two different. Man, am I just seeing this wrong? Is the question.
Maybe.
I think I'm going to have to split this up again because my inside and my outside radius is easy. My outside radius is x equals 1. So big R equals 1. Got that. But my inside radius is changing. I don't know. Well, be careful how I say it. It's changing as I go up and down because here's one inside radius. But the other inside radius goes to y2 rather than y1. So I'm going to have to do 0 to whatever this intersection is and use this little r and then do whatever this is up to 1 with a different little r. And even that's only going to be the blue part of the...
Yeah.
Is there anyone like this one?
No. I think...
So can we just skip this?
Yeah, I think this would be a prime candidate for a different method that we don't teach. Let's skip this. This is...
What's the answer?
I think it's C.
This would be a good shell method problem. We didn't even do the shell method, so...
What would the boundary even be?
You'd have to find where they intersect.
Okay, we're just gonna. Okay, that makes sense.
Second calc intersect, first curve, second curve. And it's, because they're both weird, I don't think it's going to be pi over 2 or pi over 3. I think it's going to just be something strange. 0.4979 ... And so you'd have to go 0 to a, and then a to 1 for the blue, and then for the inside you'd have to do 0 to a and a to 1 for this piece. Yeah, this is... I don't want to do this problem. The other method would be much better on this problem, and I'm guessing that's from an old... when we taught how to do shells. Yuck, I'm sorry that one's on there. So you were right to ask about that one. Basically, it would take 4 different intervals. 2 to get the blue, 2 to get the orange, and you'd have to add them all up. Yeah. because all the different R's and yeah.
Just love it.
Let's skip that one. Be done with that. Spent 10 minutes wasting our time.